So in this example, we're going to compare exponential graphs of the form y equals a to the x, where in this case, the a is greater than 1. We want to complete the table below and draw the graph on the set of axes provided over here. The graph of y equals 2 to the x has already been done, so I'm just going to label this one as 2 to the x. So we need to do the table. So 5 to the negative 2, let's think about that. That's 1 over 25, which is 0.04. Then 5 to the negative 1, which is 1/5, or 0.2. 5 to the 0 is obviously 1. 5 to the 1 is obviously 5. Now 5 to the 0.5, that is 5 to the 0.5, or the square root of 5, is 2.24. And then we can do 5 to the 1.5. Just go back and edit. So 5 to the 1.5, that's going to give me 11.18. So we're going to plot those on here. Now 0.04 is really small, it's very close to the axis on this sort of scale, and 0.2 we can't be very accurate with that, but probably somewhere around there. And then it goes through 1 on the axis, and we know when x is 1 it's 5, which is there. At 0.5 it was 2.24, so that's going to be around there. And at 1.5 it was 11.18, so that's going to be, say, here. So it's going to be the same shape of graph as the 2 to the x, but clearly it's going to go up here much more steeply, like so. It doesn't really matter that I've missed that point. You get the idea. And so, differences between the graphs. Well, if we look over here, where x is greater than 0, then 5 to the x is above the 2 to the x, and it goes up much more steeply than the 2 to the x is going to. Over here, it's below, so they cross at this point just here. List the features of the graph that remain the same or are similar. Well, the intercept, because of course 2 to the 0 is 1 and 5 to the 0 is 1, so the intercept stays the same. And notice how the negative x-axis is a horizontal asymptote for both graphs. We're now asked to investigate other values of a using our CAS calculator, and then make a statement of how the graph changes as the value of a changes. I'll probably just refer back to what we discussed here and here. And rather than using CAS, so I've got a bigger screen to look at, I'm going to use Autograph. So let's start with, as a reference, let's put in y equals 2 to the x. And we'll draw that, and that's the graph we had before. So that one there is y equals 2 to the x. Now, if I now put in that y is equal to a to the x, at the moment it's got a straight line because that's 1 to the x, and of course 1 to any power at all is just 1. But I put in a to the x so that I can actually change the value of a, and you can see here that I've got a constant controller, and I can do that. So what I can do is change the value of a. I'll keep the step to 1, and we're looking at values greater than 1, and you can see this has got a slight curve to it now. 1.1 to the x. There's 1.2 to the x, 1.3 to the x, 1.4, 1.5 to the x. And you can see it's the same sort of shape as the 2 to the x, just like the 5 to the x was, But note how they still cross here. That's because anything to the power 0 is 1, except 0 to the 0, and of course that's not defined, so we can't use that. And over here, the red one is above the blue one, but note how they cross there, so the blue is above the red to the left of the y-axis, for values of x that are less than 1. So as we gradually increase this, you'll see they'll get closer and closer together, and then obviously at 2 they'll overlay, and then let's take this up to maybe 3 to the x. And so we can see that now the blue one is above the red one, as it has been ever since the value of a went above 2. But to the left, the blue is below the red, and of course they cross here. But we can see it's the same type of shape. Now the question is, would we expect that type of behavior? Well, let's just think about y equals 2 to the x and y equals 3 to the x. So if x is equal to -1, then here y is equal to 2 to the -1, which is a half. Here y would be equal to 3 to the -1, which is a third. And of course a half is greater than a third. So we would expect that the 2 to the x graph is above the 3 to the x graph to the left of the y-axis, which is exactly what we saw. When x is equal to 0, y is 2 to the 0, which of course is 1, and here y is 3 to the 0, which is 1. So we'd expect them to intersect there. When x is 1, y is 2 to the 1, which is just 2. Here y is 3. So now we'd expect this graph to be above the other one. And that's why they cross over here, and then the other one is on top to the right of the y-axis.